myprojectbazaar.com.
Our product title is Decentralized Power Management of a PV and Battery Hybrid Unit in a Troop Controlled Islanded Microgrid.
Let us see about the abstract of our product. The proposed operational strategy is mainly focused on using an appropriate energy management and control strategies to improve the operation of an islanded microgrid formed by photovoltaic, solar energy batteries and loads. This control strategy is to achieve decentralized power management of a PV battery hybrid unit in a troop controlled islanded microgrid. In contrast to the common approach of controlling the PV unit as a current source in the proposed strategy, the PV unit is controlled as a voltage source that follows a multi-segment adaptive power and frequency characteristics curve, and also this process is implemented in the MATLAB simulating environment.
Flow diagram having three units. One is the hybrid unit, another one troop unit, and another one troop unit 2. In the hybrid unit, that having the PV panel and also the battery, and also troop unit having two kind PV panel and also the batteries. So in the main hybrid unit is fed in the AC grid bus, and also then that is fed into the AC microgrid. In that the point of coupling area, the load is connected at the PCC. In the hybrid unit, the output is fed into the DC to DC boost converter, and that boosted converter is fed into increase the voltage from the PV panel unit. After that, the voltage will be fed into the DC to AC conversion block. In the DC to AC conversion block, the DC voltage is converted into AC using of space vector pulse width modulation technique, and finally that is fit in the AC microgrid. In the troop unit 1 and 2 is a separate sources, and that sources also having DC to DC boost converter, and also that DC boosted value is fit into the AC conversion, DC to AC conversion using of inverter, and also that power electronic switches is triggered by using of space vector pulse width technique. In those three sources is only hybrid unit is the main sources. That source is fed into the AC microgrid, and also troop unities are the additional sources. When the hybrid unit not able to source supply, then that troop unit 1 and 2 is supply the voltage and current into the AC microgrid. AC microgrid is parallelly is connected in the main grid. In when the main grid supply is demanded, then that the AC microgrid is fed into supply the power into the main grid. So this process or depends on the renewable energy sources only. So the microgrid source only the renewable energy sources. In the point of coupling, the load is connected. That load may be a industrial load or commercial load may be. So in point of coupling area only the load is connected. In between the AC microgrid and AC microgrid bus, we using one transformer and circuit breaker. When that the load is enabled, then that breaker is enabled. Thank you for watching this.
Next we see about the running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB window and create a new model file. After creating the new model file, the elements are getting from the simulating library browser. From the library browser we mainly use two blocks. One is the sim power system block, another one is the commonly used block. From that two blocks we getting the elements and then arranging that elements as per given flow diagram. After that we are arranging that elements, we assigning the parameters for using of that elements, then click the run icon. After clicking that, the simulation will start, then the simulation will be ended, then the corresponding scope is connected area, we open that scope, the corresponding output will be shown. So first one is the PV panel output, DC link voltage and SOC and also pulses, and this is the DC to AC conversion inverter side output, that voltage and current waveform is shown, and this is the separate basis voltage, base to base voltage for inverter side, and this is the pulses waveform for 6 power alternating switches we used for the conversion of DC to AC. So here we 6 kind of pulses is generated. And next one is the hybrid unit inverter output, and this is the troop side inverter output, and this is the VPCC, that means a point of coupling voltage waveform for each phases, and this is the before showing waveform is the current waveform, this is the voltage waveform, and also this is the grid side voltage and current waveform, and finally this is the voltage waveform for point of coupling. We connected one load, that load corresponding voltage waveform is shown here. Thank you for watching this video.